Okay, so week 7, day 5. First up, subtract 1/4 from 5/8. Okay, so which way is my calculation? Is it a quarter take away 5/8, or is it 5/8 take away a quarter? Yeah, it's 5/8 take away a quarter, because it says subtract 1/4 from 5/8. So don't fall into the trap of thinking because this quarter is first and the 5/8 is second that you take the 5/8 from 1/4. You don't. You've got to really look and see that it says subtract it from 5/8. Okay. So I'm going to show you this again with the counters because we only met the subtraction of fractions yesterday. Okay, right, so 5/8, and we're taking a quarter away from it. So 5/8 take away 1/4. Okay, so my whole is going to be 8 equal parts. 1, 2, 3, 4, 5, 6, 7, 8, and I need my quarters just so I can see that I've got comparable bars so that they're equal. Okay, and I only want 5/8, so I'm going to take those away, and I'm going to take these away as well so that I can see that I've got my 5 equal parts. Oh, sorry, I hadn't realised that was off the screen. Okay, so it said to take away a quarter, which I know was one of these blocks. So if I look at this, I've got to think, okay, how many 8s is that equal to? And it's equal to 2, so I'm going to subtract those in. Now, if I take away these 2 8s, which is 1/4, how many 8s am I left with? I'm left with 3, absolutely. So I can see my answer is 3/8. Now, how do I do that without the cubes? Because that just doesn't look like it would give you 3/8, does it? So what we do is we find our common denominator. We're going to work in 8s. 8's a multiple of 4. So we're going to pull this down. This is going to stay as 5/8. And this time we're going to change our quarter into 8s. So what do we do to this number 4 here to turn it into an 8? We multiply it by 2. So for every 1/4, we know that there's going to be 2 8s. That's what it means when we say multiply it by 2. So that's going to be 8. And again, we multiply our numerator by 2 to keep the value the same, and the representation changes, which is going to give us 2 8s. And there we go, we were in 8s, we can take 2 away from 5, which gives us 3 8s. Fab. Okay, next question. Oh, nice. We've got a calculation that has 3 fractions that we're going to add together. Sorry, that's going to be a 5. I got a bit carried away with that. Okay, have a look at it. Again, don't just dive straight into our method. Really look at it. Is it as complicated as it looks? It's not. And it's really nice that we've got the same denominator here, because now we know we can just add our numerators, and that's great. So we can add these up. They're going to be out of 5. It's going to be fifths. It's going to be fifths. So I've got 3/5. Add 2/5 gives us 5/5. Add 1/5 gives us 6/5. So you can leave it as an improper fraction. I'd also like you to leave it as a mixed number, because that's something that we need to be able to do when we're in year 6. We need to look at converting between mixed numbers and improper fractions and leaving calculations as both and knowing how to do that seamlessly. So you've got to think to yourself, well, how do I turn that into an improper a mixed number? How many fifths make one whole? 5. So you've got 1 whole, and then how many fifths have you got left? You've got 1. So you've got 1 and 1/5 is the same as 6/5. Okay? Right, next question. Okay, write a fraction that is equivalent to 2/7. Okay, equivalent means it's got the same value, but it's going to have a different representation. So I could decide to multiply them both by 2, and I would get 4/14. That's an equivalent fraction, because whatever I've done in my denominator, I also do it in my numerator, so you keep the value the same. So you could multiply by 3 and also by 3, which would give you 6/21. Or you could multiply them both by 5, for example. So you would end up with 10/35. Do you see where I'm getting at here? It's just to do with keeping the value of these two the same. That's all it is. Sometimes you can find an equivalent fraction by instead of doubling both of these, you could half them. But in this case, we couldn't, because 7's a prime number, so it can only be divided by itself and 1. So I couldn't have 1 over 3.5, because that's already part, that 0.5 there is a part, and the fraction here, fraction that we're looking at, it's already a part. So you can't have a part within a part, if that makes sense. So we have to find an equivalent fraction that's higher. Okay? Fab. Right, last question of the week. Which number is the greatest? Right, 5.4. I'm going to tell you why I'm doing this in a minute. See if you can spot it as I'm going through. 5.14, 5.263. Why do you think I've written them horizontally and not vertically? Because I'm going to compare them. So, which digit has the biggest value here? Which has the largest value? Yeah, it's my 5s, isn't it? Which is worth 5 1s. Next up is my 10ths, which has the next largest value. Then my 100ths, which has the next largest value. And then my 1000ths, which has the smallest value. Okay? So I'm looking at these numbers first of all, and it says which number is the greatest. So I need to think, right, which of these numbers has the greatest value in terms of digits in that column? So I can see here that 5, that's equal. So at the minute, all of these numbers have the same value. So there's no greater number. Go to my next column. Right, I can see straight away here I've got 4/10. Now 4/10 is more than 1/10, and 4/10 is more than 2/10. So I don't even have to look at this digit, or this digit, because I know straight away that 4/10 is greater than 1/10 or 2/10. So this is my largest, this is my greatest number. And because 1/100th and 1,000th are much smaller parts, they're 10 times smaller than 1/10, and that's 100 times smaller than 1/10. I know that this digit here, that there isn't important, because this is the greatest value in this column here. Okay, lovely. Have a lovely weekend.